Hey there and welcome to a new review on the channel, this time with the brand new FNIRSI DST-210 3-in-1 multifunction device. It is a 10 MHz 48 megasamples per second oscilloscope, a 20,000 counts multimeter and a 50 kHz 13 waveform signal generator. Unlike the normal equipments from FNIRSI, this one has a manual handle, so I'm looking forward to understand the quality of it. As I normally do, let me tell you that this device was sent by FNIRSI for this review free of charge for me, and no payment was made by FNIRSI to produce this video. And I don't have to stick with any guidelines, so it expresses solely my opinion, and they will see this video at the same time you will when it is published on YouTube. Even so, FNIRSI is collaborating with the channel for a long time, and I would like to send a big thank you for their collaboration. But also you, my viewer, that sponsor the channel just by using the affiliate access links on the screen or in the video description whenever you want to do your shopping on AliExpress or Amazon. You will pay exactly the same, but by using these links you are helping me to maintain the channel and keep producing these videos. For your support, I would like to send you a big thank you. Well, the intro part is done. Let's get this party started with the key features. Allow me this small break to send kudos to this video sponsor, PCBWay. Being a leader in PCB fabrication, it is able to manufacture with very low price and in record time the PCBs for your project. Don't believe me? Just take a look. You get 10 PCBs double-sided for $5. It's hard to beat this. But that's not all. You can even create your project parts like custom case with their injection mold service or 3D printing, not to talk about their professional CNC machining service. It's a one-stop supplier for all your project needs, and if you use the code below on the screen, you will get a $5 discount on your first order. As usual, let's start with the unboxing. I have here the retail box for the DST-201 and DST-210. The model that I have here is the 210, that means that is 10 MHz. Okay, we have some specs in the back, very nice. Usual retail boxing from FNIRSI, and let's see what we have inside. Okay, let's open it. And first of all, we have the unit in here. Let's see what is delivered with it. We have a user manual in Chinese, English, and I think that's it. Okay. It has this protector, the FNIRSI quality assurance cards. Okay. And it is delivered with one probe. This should be the P6100, I believe. Okay. And a pair of test leads. Charging cable USB Type-C to Type-A, and a cable, 2 alligator clips to BNC. Okay, that's it. Let's now open the multimeter and oscilloscope, DST-210. Okay, so let's see what we have in here. Nice. For first impressions, and let me start with the cables, it has these test leads. It's plastic, but very flexible, and a rubber or rubber-like cap. They are very pointy. This is able to enter the breadboard if you need. Very long and very pointy. Okay, let me put the lid on again. And they say they are Cat2, 20 amps, okay, and maximum 1000 volts. Okay, In terms of that slits, that's it. And we have also the probe that is the 6100 100 megahertz, maximum at 10 times 600 voltage peak to peak. This is a Cat2 probe. Okay, that is clear, and let's now see what we have in here. If you are familiar with the products 2C23T or 2C53T, I have it here. This one is a bit higher in terms of construction, and it's about the same size. We have this rubber padding and this rubber protection that in the other two models we have it on top also. And I think the idea of this device is to be a little bit more accessible, having somehow the same or near the same features. It's plastic, you can feel it. We have a stand in the back. It's identical to the 2C53T, but a little more comfortable. I think it's a little more higher, or stand a little more right. So yeah, it's nice. The controls are using this knob, this rotating knob, and yeah, rubber buttons. We have a few buttons, also the sockets for amps, milliamps, voltage, and all the other measurements with a common. On the top we have two connectors, one for the DSO, this one on the right, and the signal generator on the left. Normally it's the opposite, but yeah, it seems to work. They are with those kind of configuration where you have to put it inside. It seems that we are able to do it comfortably. Okay. And on the right side we still have this protected connector. Let me open it. I'll try to open it. Okay. It's the USB connector for upgrade and probably removing the image if it has that function from the memory. And we have the power button on the left side, and on the bottom we don't have anything. So this is the first impressions. Okay, so let's start. And the first key that we need to use is the power to go back to this menu. And in the menu we have the oscilloscope, signal generator, settings, and the first option is the multimeter. In terms of keys, we have the mode that allows us to switch between modes. These keys should have two or more functions depending on what you are using. You have also the auto and the live, enter, and the 50%. Okay. In the bottom we have some direction keys. Probably those should be used to move in the oscilloscope the line up and down and the time range of the signal. Okay, that's it in terms of keys. Let's start by seeing how this works in terms of settings. That's the first menu that I normally cover. Okay, and to enter the menu you just use the enter. So the first menu we have language, sound and light. We can put the sound and light. The light seems okay, so I will not change it. Startup on boot, we can start up on nothing in this menu. Multimeter, oscilloscope, or signal generator. Also we have the theme night and daylight. Let me change this to daylight. I want to test it. How we do this? Enter. Okay. Yeah, I'm not sure if I want to use this. Let's go to the main menu. No, night all the way. Yeah, no, for sure no. Okay, let's go to settings. But probably there is people that like this theme. I'm not one of them. Okay, I prefer the night theme to work. And auto shutdown we have off, 15 minutes, 30 in 1 hour, very good. USB sharing to probably remove the pictures or the waveforms that you can save. You have the save button here. So if we activate it. Yeah, it's on USB, so if you connect to your PC, you should have it there. To go back in this mode, just use the power, enter again, and let's see what else do we have. And the about, yeah, pretty simple. Version 0. So I have the first version to be released. Very nice. And factory reset. Okay. You know that I always like to do a factory reset. Let's see what happens. Okay. I hope that I can finish the video. Let's power on. Okay, we have to power on again. And on startup, we have to choose the language, in this case, English. Okay, so we are back. In terms of settings, that's everything we have. Let's start with the multimeter this time. Okay, entering the multimeter. This is a very different design from the other devices. We still have a gauge progression line here on the top. On the top we have the hold. I don't see a hold button in here. Let's see if we can, no, it's the run state, okay. If we press it, the hold will become blue. We are in automatic modes, and the battery right now it's at 100%, the minimum and maximum values, and we can use this knob to change between all the values. I will test all of them ahead in the video. You have the information of what you are testing in the top. Okay. I don't see, for example, for capacitance, where is the rel or relative button. We have the run save, auto. This activates live, the live function. But I don't see rel mode. Okay, let's continue. Frequency and temperature, milliamps, and this is amps. Okay, going back to auto modes of voltage. Yeah, auto. In terms of multimeter, we don't have much to talk about. The keys doesn't do anything special. Just this one. You can use the modes to change between multimeter, oscilloscope, and signal generator. Okay, and we are back to multimeter. The run save is the hold, auto activates the live, and yeah, 50% enter does not do anything. We don't have a submenu in here. So please notice that this has 4 decimal digits, should be around 20,000 counts multimeter, 4.5 digits. And yeah, one thing that we should know also is if you do a long press on mode, you activate this visual representation of the voltage variation, and this graphic will be able to show basically in all of the measurements that you have. I don't have here yet nothing, but I believe it will be able to save here some values. It has a window, a space here reserved. So yeah, temperature and even the milliamps. I don't know if you notice this little indication. You have here the connections that you have to make on the bottom, on these sockets, but it is very fast. You hardly be able to see it. It should be here more than half second or second, because it's really fast to do this. It's very useful to have the places where you connect. A very nice initiative and feature from FNIRSI, but it should have a little more time, like the double of the time that you have right now. It will be enough. Yeah, okay, and that's it in terms of the multimeter. Let me just get out of these modes, long pressing the mode key. So the oscilloscope is very similar to the DSO-510. If you know that one, you should know this one also. We have on the top the identification of the signal output of the signal generator. Right now the signal generator is outputting a square wave. Also the time division, right now, the run state, and the vertical and horizontal positions. This can be changed, I will show you how, and the battery again. We have some measures in the bottom, and the amplitude, the trigger mode, right now it's auto with a rising slope or rising edge. Probes at one time, and we have AC coupling. Okay, very nice. So how can we change things? One thing that I notice is that if we move, even in this mode, if we move the knob, it will automatically move to the DC voltage, so multimeter. Okay, so regarding the keys, what do we have? We have the direction right and left, and those allow to move right now in terms of the memory. If you notice, it's running the memory in there because the mode here is changed. Let me see, how do we change? It's in this key, in the enter key, you change the modes as these buttons will behave. Right now we should be able to move the trigger up and down. Okay, and also the memory left or right. But let me see if we, okay, to the center. If we press again with V and H, we will be able to move the line, we will be able to change the horizontal and the vertical values. So let's change the horizontal, the time base, okay, using those two buttons, and you can move also the amplitude with the other two, okay. If you press enter, then again you will be able to move, for example, with this one, the signal, and the memory with this one. If you press again, now you have this symbol here in this side, you will be able to move the trigger. If you press for a while, I believe this should be this. Let me move again to this signal positioning, and we have the 50% here. So if you press for a while, it should bring it to the center as it happened. Okay, so it seems very easy to use. Just one more thing to change the X1 and the coupling. You do a long press on mode. We have this settings key here, and we have several options like the coupling that you can change. Okay, to change this, we use the direction keys and probably enter. Enter. So right now it's in DC mode. The probe, it's one time. We can change also to 10 times the modes, and the edge. To change to the other menu, just use the direction right and left. Again, we can navigate. I hope, I don't know where am I. Okay, it's in here. You will be sequentially moving the cursor through all the options, and you can activate the ones you want. For me, I would like to have, I don't need the duty cycle, okay, but frequency and VPP is a must. Okay, so that's it. The persistence, we have persistence, 500 milliseconds, 1 second or infinity. And the image, I already saved one image, so we have it here in BMP format. And I believe that's it. This is a very simple device, but seems very complete. So in terms of signal generation, it's very similar, I believe, to the 2C53T. It has a maximum of 50 kilohertz sine wave. I'm not sure if the square wave will be also 50 kilohertz, I believe so. You just use these keys up and down to navigate the option that you want, and then when you, for example, on sine wave, you just press enter and select the frequency. Okay, with the navigation keys you have to select which option, enter again, and you can select your option. With the right and left you can take the cursor up to the desired values. Let's put this at 50 megahertz. I believe it's the maximum, 50,000 hertz, so 50 megahertz. The amplitude, I believe that we can change the amplitude also. Let's see. Okay, again to the right, and we cannot go any further, and the lowest is 0.1 volts. The maximum is obviously 3 volts. Okay, those are the options, the way you can work with it. If you want to go back again, press menu, I think. Yeah, menu will go to the main menu. It's the auto, sorry. And again, the square wave has the percentage of the duty cycle, but that's the same way of working of everything else. Okay, that's it in terms of signal generator. I will now start testing all the features of this multimeter dash oscilloscope. I have the DST-210 connected to my function generator with the probe already compensated. We are right now with 1 kilohertz frequency with a VPP of 5 volts. And for controlling the function generator, I'm using my mouse, so I will not disturb the probe that is connected to the function generator with an adapter. And right now we have 1 volt VPP. Let's do an auto to see also the detection. So with 1 kilohertz we have 992 millivolts of VPP. This shouldn't go below 720, more or less. That's the minus 3 dB for bandwidth analysis. So let's start testing this. Right now I have one with 1K. I will pass directly to 1 megahertz up to 10 megahertz. That's the maximum bandwidth supported of this device. Let's start then with 1 megahertz, 1 megahertz. Okay, again, auto. I'm using square wave. Let me change to sine wave. I will test the square wave again later. Let's do auto again. With 1 megahertz of bandwidth, it's detecting without any problem, and we have a 960 millivolts of VPP. Okay, seems nice. Let's take it to 5 megahertz. Okay, auto again. So the time range now it's 100 nanoseconds. We have 874 millivolts of VPP at 5 megahertz, and it's detecting pretty well the frequency. Okay, since we are at 5 megahertz, now I will change the probe to 10 times, and also, let me see, okay, let's go here and change the probe also to 10 times. Okay, okay, both, that's it. Let's see in 10 times the 5 megahertz. Okay, still around 870, 5 megahertz identified, no problem at all. Okay, let's go directly to 10 megahertz. 10 megahertz, and we are at 10 megahertz. Let's see what we have here. Okay, we are now with 50 nanoseconds of time base. It's detecting 10 megahertz, and the VPP is around 720. So is really on the borderline of the 10 megahertz, but I take this as good. Yeah. Okay, good news. I think that's okay. Let's see if I can change this manually, like this. So 12 megahertz, 11 megahertz, it goes immediately below the 700, but that's fine because the limit is the 10 megahertz. Okay, in terms of bandwidth, seems nice. Let's now see a square wave. Well, square wave, it's always a bit tricky. So a 10 megahertz square wave, let's do it auto. Yeah, this should be a square wave, but it doesn't look like. On the positive side is that the VPP is a bit higher right now. Okay, let's change this to a 5 megahertz square wave. Still really not square. And 1 megahertz square wave. Okay, auto. Yeah, this one seems okay. 1 megahertz, 960 in terms of VPP. Let's increase this slowly. So 3 megahertz should be around what we get. Yeah. Oops, sorry. Touch here. Yeah, we are stretching this. It will be able to see up to, let's say, oops, not this, cancel. Let's change it to 2.5 megahertz. Should be around, yeah, 2 megahertz should be the maximum that you can have a square wave. Even so, the VPP seems fine. The frequency identification also. I can show you also the ramp. Well, in terms of bandwidth analysis, that's it. We checked that he really has 10 megahertz supported. So that's good news. Let's move on. On the screen, I have already my Rigol DHO924. It's displaying the output of the DST-210, the signal generator or function generator. And I will do first a quick check on all the waveforms. So we have the sine wave. Let's see the square wave. Very nice. Okay. Sawtooth, half wave. Okay. That one needs auto again. Very precise. And we have also, let me show you here the value. So we have a VPP of 1.5 and the frequency of 1 kilohertz. So it seems okay. Again, let's go down. Full wave, step wave. This is the reverse step wave. Let me show you this better. This is the index up, index down, and we have direct current at right now at 3 volts exactly. Okay, multi-audio and sync pulse, and final Lorentz. Very nice. Okay, let's now take this to the maximum and see how the signals will perform. Okay, enter, and I believe that the maximum is 50 megahertz. Let's increase that to 50 megahertz, that's it. And let's see the quality of the waveform. It seems nice. Okay, the frequency is identifying also as 50 megahertz, and the VPP 3.01, yeah, something like that. Let's see the sine wave with the different amplitudes. Okay, for that we will bring it down and change this to 1 volt. Okay, auto again. And now we have 0.1 volts in terms of VPP. Okay, still good, some deformations here, but the voltage is very low. Okay, back to 3 volts, exit. Okay, we are back to the 3 volts. Signal is perfect at the maximum bandwidth. Let's now see the rest of the signals. Square wave. So square wave has a little bit round edges here and here, but yeah, at the maximum of the signal I can accept this. So sawtooth, half wave, again auto, full wave, seems good. Well, the step, it's very round, this step. Let me do auto again. Yeah, it has a round steps. It's not perfect, not at all, but again, is at the maximum. So reverse steps. This is the index up. Well, this corner is a little bit rounded also, but in terms of the VPP, it's a little below the 3 volts of amplitude. The frequency is okay. Okay, this one is the index decrease, so it's the reverse index. It says direct current, but it should be voltage. But anyway, so the voltage signal is a 3.31, more or less. Let's go down. Multi-audio, seems nice also. Sync pulse. And finally, the Lorentz. It's basically more or less what we had with 1 kilohertz. So in terms of signal generator testing, that's it. Let's move on. I have my setup for testing the DST-210. This time I will use my Owen XDM1241 for checking the values of the DST-210. Also, as source of voltage, I will use this 0.02% grade voltage calibrator. So without further ado, let's start with 1 volt. Okay, with 1 volt I have 1.0002 on the DST-210 and 0.99987 on the Owen. Okay, very near. Let's continue. 2 volts. Okay, spot on DST-210 and almost there, 1.9996 on the Owen. Let's continue. 3 volts. Spot on again on the FNIRSI. Almost there on the Owen. 4 volts. Again, this one has 1 more digit, so if you round it, it will be spot on as we have on FNIRSI. So for me, it's very nice, also good. And in 5 volts, the Owen is spot on, and the FNIRSI, it has 1 digit more, nothing really serious. 6 volts. Okay. The Owen is taking his time. Okay, 5.999 and 6.001. Very good also, very near. Totally within the error margins of the FNIRSI. FNIRSI has a 0.5% plus 3 digits as error margin. So only the 3 digits will be justify the difference. And in 7 volts we have 6.999 and 7.002. 8 volts. Okay, 2 digits over, 1 digit below. 9 volts. Also very near. As you can see, the 3 digits difference maintains, so this is very accurate. And we are back to 0. Let's go to 100 millivolts. On millivolts, we have a spot on FNIRSI and a spot on Owen also. 200 millivolts. Okay, spot on Owen. almost on FNIRSI, 300. Okay, we still have a spot on Owen, almost on FNIRSI, 400. Very accurate, both devices. Spot on Owen, almost on FNIRSI, 500 millivolts. We keep the spot on almost on Owen, and we are 3 digits over on FNIRSI, two digits over, and 600 millivolts. Okay, still spot on Owen, almost on FNIRSI, a difference of 3 digits. We continue with the 3 digits difference between both of devices. 700 millivolts. Okay, almost spot on Owen. 700 and yeah, still almost the 3 digits difference from Owen to FNIRSI. Very nice. 800 millivolts. Spot on Owen. No, 1 digit over, and 4 digits over on FNIRSI. So still the difference of 3 digits. And 900 millivolts. So on FNIRSI we have 0.9005, yeah, a bit over, and on it's almost spot on, it's oscillating a bit. So back to 0, let's go to 10 millivolts, let's start. Spot on Owen and spot on FNIRSI, very nice. Okay, 20 millivolts. Spot on FNIRSI, and Owen almost there. 30 millivolts, spot on Owen and FNIRSI. 40 millivolts. Okay, both very accurate, spot on. 50 millivolts. Okay, still good. 60 millivolts. 70 millivolts, very accurate, both of them. And this one was 1 digit over and also Owen. Okay, they are in sync. 80 millivolts. Okay, exactly the same value, spot on. And 90 millivolts, also the same value, very nice. Let's go to 1 millivolt. Okay. Both of them with 1 millivolt, 2 millivolts, 3, still very good, they are in sync almost. 4 millivolts, almost there in FNIRSI, yeah, 5, 6, 7, yeah, we have a difference. No, we don't. Okay. Yeah, it's oscillating. 80 and 90 and back to 0. And we finish this way the DC voltage testing. I will now measure AC voltage. For that, I will start to connect to my socket the ground. And now let's see what we have. So it's measuring 235, 236, and I think this is okay. If you notice here in the corner of my socket, my intelligent socket for the workbench, it's saying that we have around 237, 38. It's more or less what we have in the DST-210, so it's a pass for me. While I have the socket on the workbench, I will take the opportunity to test also the live function. To activate the live function, just press on auto, yeah, like this. And let's see what we have in terms of live function. I will start by using the red test lead. We don't have anything in this one, and we do have contact in the second hole. Okay, very nice. One thing that is also cool is that you can also test with the black probe. So let's see it. Yeah, it detects energy anyway. So also a pass. Let's continue. For a milliamps measurement, I have my SG004A process calibrator. it will be able to measure from 0 to 24 milliamps. It's connected right now to the DST-210, and let's start to see how it behaves in terms of milliamps measurement. So 1 milliamp, it reads 1.014. Let's take it to 5 milliamps. Okay, almost spot on, just 3 digits, 5 digits over. Okay. 10 milliamps. Okay, very near. 15 milliamps. Also near. Okay, it's still stabilizing. And 20 milliamps. Okay, it's just a little bit below, almost spot on. And this is the maximum, 24 milliamps, and it is spot on 24 milliamps. Very nice. Now I will measure in series and see what is the maximum in terms of milliamps that we can measure. We are now in amps, and I am already outputting 100 amps, and I will take it from here to measure all the way up to almost 10 amps. Let's start with 500 milliamps, so it is almost spot on. Let's take it to 1 amp. So it is reading 0.9991. Okay, so let's take it all the way to 2 amps. Almost there, almost spot on. Okay, 3 amps. This is spot on almost. 1 digit, yeah, spot on. 4 amps. 4 amps, it passes 4 digits, okay. 5 amps. Okay, 13, 14, 15, 16, yeah, it's still increasing, but it's a bit over. 6 amps. Okay, 6 amps, still some digits, and still continue to increase. If you guys know why this happens, let me know in the comments. Okay, 7 amps. It's a bit over. If you notice the power supply, it's with 7.011. That's fairly accurate. And we have 7.100 and something, and still increasing. This is a bit weird. And we are now with 8 amps. Still increasing the decimal points. Okay. And all the way to 9 amps. 9.25060. It continues to increase. So I will take it all the way to 9.9 amps. That's the maximum output of the power supply, and the power supply is fairly accurate in terms of output, but we have 10.300 already and still increasing. I don't know if you guys know why this happening. This should be stabilized already, and it's still increasing, but I will kill the channel right now because the maximum from the manufacturer is 9.99. But yeah, that's it. Let's continue. Now it's the time to test some resistance. I have here already my 0.1% 25 parts per million precision resistor board. Yeah, we will start with 10 ohms. Let's see what we get. 10.41, okay. The second value is 100.03 ohms. 101, a little over. The third value is 1.0003K, so 1K. Okay, not bad. Let's see this one, it's 9.995K. 9.989, okay, very near. And the last one is 100.0604. Yeah, something like that. Let me see. 100.0. This is almost spot on. Very nice. Okay, so I have also this board. It's a decade board, 8 decades programmable resistor board. and it starts with 1 mega ohm and it finishes with 0.1 ohm. In terms of error margin, it has 1%. It's a error margin bigger than this one, it's 0.1. But anyway, let's see what we have here, for example, for 1 mega ohm. Okay, 1.0012. This is almost spot on, very nice. So this should be 100K, 99.98, very near. This one should be, let me see, 10K. Okay, 9.89, 88, very near also. And 1K, let's see, 1.025, very nice. Don't forget, these are 1% resistors. Okay, so the next one should be 100 ohms. Let's see what we have. 100.9, nice. 10 ohms, 10.45, and 1 ohm, 1.33. Let's see on the top what we have. Okay, let me check. .84. I think this also depends on the resistors that you are measuring. Yeah, 1.33. Okay, and 0.1 ohms, 0.60, 47. Yeah, these lower values are more difficult to get some correct values. Okay, that's it what we have in terms of resistance. Let's move on. So now let's test some capacitance. I will use again this reference board, and the first value is 102 picofarads. Okay, so we have 116. To be honest, the last devices that I tested, they all gave values around 112 and 114. So I believe this should be more or less accurate. Let me see. The second value is, okay, 1.02 nanofarads, 1.6, very near. The next value is 10.4 nanofarads, 10.6, also very near. This value is 98.7 nanofarads, 100.3. It's a bit over, but also near. This last value has the value of 929 marked, but I don't think this is correct. It should be around 880, 890. It's what I always get in the multimeters. Yes, 880, so I take this as correct. And the last value is 10 microfarads. Let's see what we have. 10.37. Okay, very near also. So in terms of capacitance, that's what I have for you. Now is the time to test some diodes. Let's start with this one. Let's see, it should be 580 millivolts. On the reverse, it shouldn't give any value. Okay, that's correct. Okay, and we have also this one that should be 1.7. And this, I believe it should be 2 point something. Let me see. Not right. 2.6, yeah. Very nice light. And this should be around 1.72, I believe. Let me check. Yes. And I have another one. This is a new one in this test I make, but it will give you a very low light, but it's a 1.8 diode. Okay, that's it in terms of diode testing. Well, now let's see in terms of continuity, the speeds and the sound of the multimeter. It seems very fast, but the screen does not respond. Let me see. It takes about 2 to 3 seconds to respond. 1 Mississippi, 2 Mississippis. Okay, so 2 seconds to respond with values. The sound itself, it's not too loud, but it's very fast to respond. In terms of the time, the response time, it's very fast. Okay, that's what we have. Let's move on. This one didn't come with a temperature probe, but I have mine already connected. Let me just move my monitor to see. In this room it is 25 degrees. We have it here and it seems correct. Let's now see my body, outside body temperature should be around 32 to 33 degrees Celsius. So let's see what we have. Yeah, so this should be about right. It's the normal temperature. Today it's a hot day here in Portugal. So 35 degrees is nothing special. I think this is correct. So let's move on. In terms of frequency, the DST-210 should be able to measure, according to the user manual, from 10 Hz to 10 MHz, or more precisely 9.999 Hz to 9.999 MHz. So I have here 10 Hz already in the signal generator or function generator, and it's reading 10 Hz. Let's try 100 Hz to see the precision. Okay, spot on again, very nice. Let's take it to 1 kilohertz, spot on, and 100 kilohertz, also spot on, very nice, very accurate. 1 megahertz. Okay, we continue, very good. And 5 megahertz, also nice. It has 3 digits over the value, not bad. And let's take it to 10 megahertz, the maximum. Also spot on. So this brings the question up to how much it will be able to read the frequency. Let's do it manually. Okay, let's take it to 15, 20, still spot on, very nice. 25, 23, 22, 22 is spot on, 23 still spot on, 24, yeah, still very near, and that's it. It closes at 24. After that we don't have any more results. Yeah, still the manual says that it will be able to go up to 10 megahertz. You can measure without any issue up to 23, 24, and probably something else here. Yeah, 24 and a half. No, it's 24. Okay, still very good, very nice and very accurate. Let's move on. Wrap up time, and as I usually do, I will start with the price analysis. It is on sale on FNIRSI AliExpress official store at around 50 euros, or for my American friends that should be $55 for the DST-201 1 MHz version, or 60 euros, that translates to $67 for the DST-210 10 MHz version that I covered in this video. On FNIRSI products, the closer comparison that I can do is with the 10 MHz 2C23T at 75 euros or $84, with a bit higher price but with 2 channels. So, considering the features included, the price is in line with FNIRSI offers for this kind of devices. But even if you consider the competition, like the 10 MHz one channel Zoe ZT702S, or also the 10 MHz Aneng AOS02 Just to mention two known examples, the price is also in line with this device. The construction is good. Personally, I would like to see a bit more of that non-slip rubber or silicone around the device to make it more slippery resistant. In terms of the selector knob, it needs the right amount of force to rotate it. And if we are talking about also the keys, they are rubber or silicone-like material that will give you a good grip while using them. The interface is modern and easy to use and is aligned with the FNIRSI latest models firmware. So if you already work with one, you will feel right at home. The display is in line with the other models mentioned before and has a very nice quality. And it is easy to read the values, at least indoor. I received in the day that I'm recording this video a comment on another video already published, complaining that these reviews never show the outdoor usage and how hard it is to use this device outside. Well, challenge accepted! And I went outside to see how it will handle the daylight brightness, and this viewer was right. The glassy finish on the screen creates a very big reflection, and the brightness of the display, while it was on the maximum, didn't help a lot to see what was on the screen. It was barely visible. So consider this if you are considering to use it mainly outside. The oscilloscope does what is announced. It has real 10 MHz, at least using the -3 dB tests to evaluate the analog bandwidth, and provides you with the minimal features to work with. It has measurements, persists, waveform image saving, and a certain waveform signal generator. In terms of multimeter, the accuracy is good enough. One of the weird measurements that I usually get in these multimeters is the temperature reading, but at least in this DMT-210 seems accurate, and also the live function works with both leads, while normally this happens only with the red test lead, so it is a nice feature to have. It has the indication where to connect the test leads whenever you select a function that will require to move the test lead. But on this part, I would like to see that indication a bit longer on the screen. It is too fast to disappear. Personally, I like the manual knob, so if you are old school, you probably like to work with it also. Overall, it is a good device to have, and if you are on the market for a device like this, and the DMT-210 is the one. Please remember that if you use the links on the screen or in the description to access AliExpress or Amazon to buy it, you'll be sponsoring the channel without spending a cent more. I really appreciate your sponsorship, and from my part, let me leave here a big thank you for your support. What doesn't cost a cent more is your slap in the like button if you like the video, and if you are new here or just didn't subscribe yet, by subscribing it will help you to be on the loop with all the cool test equipment devices that hit the market, and every week I receive a review here in the channel. That's it for today. Let me thank you for your time and company while watching this video. I hope to see you in my next one. Until then, take care.